During an experiment, some water was removed from each of 6 water tanks. If the standard deviation of the volumes of water in the tanks at the beginning of the experiment was 10 gallons, what was the standard deviation of the volumes of water in the tanks at the end of the experiment? Okay, so we got 6 tanks. And they all have some amount of water in them. And we don't know necessarily that they all have the same amount, and then some water was removed from each of them, and we also don't know that the water removed was the same for each of them. All we know is the standard deviation was 10 gallons originally. And so let's say my 6 tanks are A, B, C, D, E, and F. And so I don't think I have ever once on the Gmat had to calculate standard deviation, at least not calculate it by plugging into some formula or anything like that. I don't even really remember the formula for finding standard deviation. So I just really sort of have a conceptual understanding of what standard deviation is, and I think that is all you really need for the Gmat. So standard deviation is a measure of spread, is a measure of how far on average are each of your terms from the mean. So in this case, it's a measure of how far on average are the gallons of water in each of my individual tanks from the average amount of water for all 6 of the tanks. So we're saying originally that number was 10 gallons. And so without knowing anything about how much water was removed from each of them, I can't really say anything about our new standard deviation. So let's look at our statements. Statement 1, for each tank, 30% of the volume of water that was in the tank at the beginning of the experiment was removed during the experiment. Okay, so let's say, so originally we had our 6 tanks here, and we had A gallons here, B gallons here, C gallons here, etc. And we also had some mean, and we'll say that mean is X, like that. And so now, after we remove 30% of the water from each of our tanks, should now have 0.7 A gallons here, 0.7 B here, 0.7 C here, 0.7 D here, 0.7 E here, and 0.7 F here. And my mean should now be 0.7 X. So let's think about this. So before, originally, how far were, let's just look at maybe 2 examples, A and B. So A, how far was that from my mean? So that would be X minus A would have been this distance, and then B would have been X minus B away from the mean. So now, how far is A from the mean? It should be 0.7x minus 0.7a, and b should be 0.7x minus 0.7b. And once we factor out this 0.7, we can see that, and this will be true for all of our tanks, the distance that all of our gallons for individual tanks are from the mean amount of gallons is going to be 70% of what it was before. And so if on average, our distance is 70% of what it was before, then our standard deviation should be 70% of 10, which is just 7. And so I can sort of figure that without necessarily knowing any of the values for the gallons of water I have in any of my tanks. I know my new standard deviation will have to be 7. So this is sufficient. Statement 2 says the average volume of water in the tanks at the end of the experiment was 63 gallons. So we got to figure out about statement 1. And so I have no idea how much I had to start in my tanks. I just know the standard deviation was 10, and now I have 63 gallons in each of my tanks. Now, let's think about this. So I have no idea how this affected the distribution of my water. So I could have, say I had 100 gallons total before. Well, I could have removed 37 gallons from one of my tanks, or I could have spread that out across 2 tanks, or I could have spread that out evenly across all of my tanks. And all of those cases are going to result in different standard deviations. I don't know what those standard deviations are, but without knowing something about how the removal of the water was distributed, uh, I can't really say anything about what my new standard deviation is going to be. So statement 2 is going to be insufficient. I'm left with just A, and that's without having really calculated anything. It's sort of just being able to maybe diagram it and thinking about it. A.